Hello, intrepid geonauts. Um, Dr. E here to teach a lab. Excuse the hat. I've been wearing it all day for field trips, and now my hair looks, yeah, let's keep the hat. Um, let's learn about metamorphic rocks. Wipe this quick. Oh, is that a little better? That's a little better. So, obviously didn't get a ring light yet. It's copacetic. Well, I have a ring light. I just have to remember to bring it in. So, metamorphic rocks. These are your rocks, your metamorphic rocks. We did the first eight, then the next eight, it's your last eight. So, metamorphic rocks, you're going from 17 to 24. Let's go ahead and check out this lab. The first exercise in this lab is pretty straightforward, especially with the tips I'm about to give you. The second one we will talk about. Second is it's a little bit like sedimentary rocks where it's way more advanced than I would ever expect my geo. Usually, what I would usually expect from my geo students. Uh, but we'll work through it. We'll work through it. So in the metamorphic rock identification, first of all, you got to go through these explanations here. That's going to help a lot. Let's talk about the couple of ways that we do ahead and we identify what we're looking at. So I'm going to do a little bit like the sedimentary rock slam, where I'm actually going to do you a solid and help you identify, there's my acid, help you identify about four of these rocks, and then you only have to identify four of the rocks. So I'm going to stop share. The explanation they give on how to identify a metamorphic rock is a little convoluted. There's no reason to make it super complicated. We're going to go down the steps and we're going to go straight and like narrow things down one by one. And so the first one we're going to look at is we're going to look at the first one, which is number 17. So let's talk about foliations. Foliations are bands or ordered structures inside the crystal structure where they all have a similar orientation, and that's caused by stress. So, for example, in this rock, what we can see is that the foliations are running this way, so stress was applied this way. Number 17 is foliations are very clear because they are big, bright bands. That's not always going to be the case. So, for example, number 20 is also foliated, okay? But you have to usually turn the sample to see it, and it looks like thin sheets rather than those clear, bright bands. Now, take a look at two that are non-foliated. We have number 18. Number 18, if you look really close, and you're going to want to like really look at it. The hand lens might be useful in this one. Pull out the hand lens. Get a close look at that guy. Number 18. And when I see those crystals, they're the same size in every direction. Okay, they're randomly ordered. They're not all ordered in the same direction. So non-foliated. Another classically non-foliated rock is number 21. Let me pull out number 21. See, I'm helping you out here. Number 21, it looks both number 18 and 21 because of the new crystal formation, neocrystallization. You have it coming out, it looks almost like sugar, but you don't see any particular orientation to those crystals. So if we went through this, number 17 we said was non-foliated or was foliated. 18 was non-foliated. 19 is a hard one. 19, you got to look at it from the side. Once again, look at it from multiple angles. And you can see there's kind of like, it looks like almost like if it was sedimentary, you might say that's like, oh, that's some kind of bedding plane or sheets. But what that is the orientation of the crystals. So 19, definitely foliated. 20, Once again, hard to see, but you can see if you turn it from some angles, it almost looks like layers. 20 is foliated. 21 is non-foliated. Now you only have to figure out the foliations on 22, 23, and 24. Next thing, grain size. What they mean is crystal size. So a good way to see how big the crystals are, if you pull it out and you take a good look at it, and you don't need to use a hand lens, and you can see individual crystals. Once again, they will look like a little bit like salt crystals or sugar crystals almost. Those are the mineral crystals. Number 17 has a lot of mica and it has a lot of quartz. So you're going to have some different shapes to your crystals in there, but you'll see these big flakes. And so 17 is pretty obviously very, very coarse. So we describe that as coarse. If we go ahead and we look at number 18, let's go with 18 again. How do they define it? Yeah, that works. We'd say that this is coarse. Okay, I wouldn't have to use a hand lens. I can see it. Once again, it almost looks like a block of sugar. And so that means that it's definitely got crystals I can see. Compare that to number 19, where we're going to have, we look at that with our naked eye, we can't see crystals. We take out our hand lens. We still can't really see crystals. We see that there's a pattern, a sheeting, an orientation, but we don't really see crystals there. So number 19, we would say it's got fine grain size. And number 20, I know which ones they are. I don't have a key. They don't give me a key. But I know what this is because it's very distinctive. So we look at it with our naked eye. You can see some crystals. We might describe that as medium. So I would honestly describe it as fine, but the way that it's categorized, it's medium. So we'll call number 4 medium. Other textural qualities. We'll go back there and look at that list again. Let's take a look at the composition list. Okay, that's the mineral makeup of it. So how am I going to be able to identify minerals that I see? One mineral that's easy to identify is calcite. So if I take a drop of acid and I put it on each of my 4, I'm going to let you do that. Put a drop on each of your first 4 and look really close. I'm going to let you go ahead and do that. All right, did any of your 4 fizz? You only really need one good sized drop of acid. You don't need to soak it. One of them should have fizzed. It's number 18. So if it fizzes, what mineral is that from our mineral lab? Wait for it. Calcite. So number 18, we already know. We know what 18 is. It's non-foliated. It's got coarse grain size. It's calcite. There's only one that's calcite. Number 18 is marble. Now, the other ones are going to be a little bit harder to identify. Quartz, you can kind of figure out if there's quartz in there, if it scratches glass, but most of these are going to contain quartz or close relative like feldspar. That's difficult to tell especially for a novice, when they're looking at the rock. Micas, okay, like muscovite and biotite are easy to identify. Why? Because they look shiny, shiny and glittery, glittery. So if we pick up number 20, we've got the shiny, shiny, glittery, glittery. And I can see that, oh, that's definitely this is rich in mica. It's also got what looks like almost like chocolate chips in there. Those are garnets. Okay, you wouldn't be able to figure that out from this lab in their directions, but trust me, they are garnets. So what are the identities of these fellows? So we already figured out one of them. So number 17, big, clear, bright foliations, really distinct. Number 17 is a highly, highly high-grade metamorphic rock known as gneiss. It's very common. It's very common in the North Country. Number 18, we already identified. What did we find it to be? Marble. That's correct because it contains calcite and it's non-foliated. Number 19, we've got these flat platy crystals. Okay. And there's a couple of these that we could identify it. There's a little bit of that muscovite shimmer to it or biotite shimmer. For this guy, I would definitely take either slate or phyllite because it's got that plains orientation. And then number 20 is what's known as a schist. Okay? It's foliated. Now, what's not clear here in the diagram is that they're organizing is from least foliated to most foliated. So slate is the least foliated. You just see fine plates, whereas big crystals, in clear planes, that's more of the nice end of the category. So we've identified 4 of them. Now, pro tip, if you think it's something, if you think it's one of these, throw it into Google. See if what pops up kind of looks like your rock. Okay. Don't do it the other way around. Don't use like Google Lens because you will end up with legit nonsense. But if you're stuck between 2 identities, don't be afraid to Google each one of those and see which one it looks like. In fact, it wouldn't hurt to necessarily Google all of these ones and just have an idea of what you're looking at. Now, we've identified these first 4. Let me give you a hint on number 21. It looks like marble. Okay, so it's got a lot of the same qualities of marble, but it doesn't effervesce with acid. So it's non-foliated and it doesn't effervesce with acid. And then a hint on number 23, look at the composition. This kind of black powderiness. What do you think that is? Black powder. And yeah, that should clear you up for the metamorphic rocks. Email me if you got any questions. I'm very confident people did pretty well on the minerals. I mean, it's really hard. I'm sorry, I'm itchy. I gave blood and the stuff they use to sterilize always makes me a little itchy. So, yeah, you've done this, you've done this very similar things with minerals. You did it with igneous rocks, you did it with sedimentary rocks, and most people that are keeping up with the labs did well on those. They did pretty gosh darn good. So I'm going to say I trust you, at least with exercise 1, to do really well on this. Now let's move on to exercise 2. So exercise 2, so in the sedimentary rocks, I was like, yeah, that's more of like a historical geology, Geo 132 type thing that they're talking about there in the sedimentary rock, like deposition types. That's a little bit hard, especially with the amount of information that you have. This here, some of this stuff on this exercise too, I didn't see to grad school. So I'm going to say try your best and give a reasonable answer, and I will grade it based on reasonable answers. So, you can't put nonsense. You can't be like, ooh, it's a shale. Shale is unless it's a protolith. So let's talk about protoliths. Protolith, reminder, that's the rock before it goes through metamorphism. So, and then we have use the table information in table 3 to determine which metamorphic texture you would find most likely in each of the mineral zones listed in data table 2. Here's data table 2. So these are the mineral zones. This is so what they're not connecting here is that low grade metamorphic rocks I don't know if it had in the description, are going to be slaty or phyalitic, in other words, like phyllite, whereas high grade are going to be gneissic. So how do we do this? Let me go ahead and go through chlorite with you. We see the mineral chlorite. We go up to our table And we see chlorite is found under low grade, and it's only under low grade. And the rocks that we find chlorite in are slate and phyllite. So a fair guess for the kind of foliation is a slate-like, which is slaty, or phyllite-like, phylitic. Foliation. Additional metamorphic minerals, that's just the rest of this list. So that's muscovite, biotite, quartz, feldspar. I can spell feldspar. Who says that I can't? Oh, oh, oh. How many times am I going to do that? Let's do biotite. Biotite is here. Where do I see biotite? I see biotite across all of them. So I would say all. And I can even just type all there. Makes sense? Awesome. So use the info. So that's continue on with that pattern. It's just connecting this diagram to the. So like you find the mineral up here, what list it's in. If it's a low grade metamorphic rock, it's going to have a slaty or phylitic um, uh, foliation. If it's intermediate, it's going to be phylitic or schisty. Or if it's high grade, it's going to be gneissic. So identify 2 metamorphic minerals you find in each mineral zone. Use the information table 3 to determine the metamorphic grade of each of the numbered zones in the metamorphic zone map. So this is the part that I'm like, this is grad school stuff. Because like, first of all, there's multiple orientations for the words and no symbol of whether or not it's like which way is north. And that's just bad map making. So what am I looking at here? This is an imaginary map where metamorphism has occurred. In this case, we'd have some kind of folding. This looks like either a plunging anticline or a plunging syncline. Neither one of those you need to know anything about for this class. Until I think there's a lab that, not plunging, but you'll know a little bit about anticlines and synclines later. So use the information in table 3 to determine the metamorphic grade of each of these zones. So this is a chlorite. So let's go ahead and do 1. So this is a non-foliated biotite. So if it's non-foliated biotite, non-foliated means it's low grade. Oh, I closed the lab. Dios mío. That one. Okay. An exercise 2. Oh, and it deleted my work. Oh, well. So zone 1, let's look at that map again. Where's the map? Here, I'll put this next to it. Let's see if I can do this. And that. Oop. Okay, so let's take a look at this. So number 1 is biotite. Biotite is in all of them. Biotite is a very common mineral in metamorphic rocks. This biotite is non-foliated. If it's non-foliated, it's going to have a very low grade metamorphism. So what we're going to put down here in table 3, zone 1, is non-foliated or low grade. Then we go back up here and it says contact metamorphism or regional metamorphism. So, and that has to do with the general temperature and pressure that we're going to see. I don't see how they expect you to be able to interpret this. And apparently there's a ton of stuff going on outside outside my office right now. It's a little party out there. So 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 if it's non-foliated and it's low grade, most of the low grade is going to land in contact metamorphism. So we'll say contact. They really don't give you enough information to do this accurately. Just a second. So number 2, let's talk about that. That's the staurolite zone. Staurolite, if we go up here to our table 2, we see staurolite is in the intermediate grade. And so we would go ahead and we would put intermediate. So you can see that the connection to the metamorphic grade is going to be a lot more straightforward than the contact or regional metamorphism. Just do your best for contact or regional metamorphism. They don't really give you enough information for that, but this is really just going back to that table 3, and just connecting that to, is it non-foliated, in which case it's low grade, or if it's foliated, which means it's either intermediate or high grade, then which mineral category does it fall in? And if they have both, you can put a slash. Now, protoliths and metamorphic grade. On this last section, use the information given the exploration to assign a metamorphic grade, and record that in data table 4. Using the information exploration, determine a possible protolith for each metamorphic rock samples. Record that in data table 4. So these are the samples that you had in your lab. It's not letting me fill it in. If that happens to you, just email me. But this is as simple as going back to the charts in the exploration portion. So you put the rock name here. So like number 17, we figured out that was gneiss. The metamorphic grade, that is the highest of the high grade metamorphic. We see that at like continental collisions. A protolith of gneiss listed in the exercise, I guarantee you, is granite. So you just continue that for each one of the rocks that you identified. Then you give some definitions, and that's it for the lab. Once again, this is not a perfect lab. Don't be afraid to reach out to me if you have questions. And I appreciate you. Thank you very much for your patience with me and your patience with these imperfect labs. And yeah, thanks for being my student.